Hello, everybody. Welcome to this Transforma Insights webinar, or virtual briefing, I should say, navigating the increasing complexity of IoT regulations around the world. Just a few quick words of housekeeping before we get going. The webinar will last for about an hour. We'll have something like 40 to 45 minutes of presentation, and then we will go to Q&A. If you want to ask a question during the course of the session, then there is a Q&A box you should see it at the top of your screen. Drop your questions into there and we will get to them at the end. And in fact, we ask people to submit questions when they registered, and we already have 4 or 5 interesting ones in the hopper that Nir and I will get to at the end of the session. Just to preempt the usual first question, which is, can I get a copy of the slides? Yes, those will be available almost immediately as soon as we can upload the presentation, as well as a recording of the session. The slides are also available. They'll be available on the Transforma Insights reports and insights page. As I say, almost immediately after the end of the session. It's a few hours to get it up and loaded. So without any further ado, let's get things kicked off. First things first, who are your speakers for the day? Well, I'm Matt Hatton. I'm one of the founding partners at Transforma Insights. We're a boutique research and consulting firm focused on IoT. More on that in a moment. Nir, over to you to introduce yourself.
Yeah, hi, good afternoon, good morning, everyone. Good afternoon, Matt. It's good to be again in the Transforma Insights webinars. Nir Shalom, the CEO of floLIVE. Thank you.
Excellent. So, quick run through of the agenda. What we're going to be talking about today. Well, we're going to be talking about regulations. Hopefully that won't be much of a surprise to anybody who's joined us. We're going to be talking about all of the regulations relating to IoT. Pretty sure we won't have much of a hope of getting to all of the regulations associated with IoT, but what we're going to do is pick out what we think are the key regulations that are affecting enterprise deployments of IoT and some of the issues surrounding those. And we've identified a series of these, and we'll run through them one at a time. First is around vertical regulations, then we'll get on to device certification, talk a bit about permanent roaming, then privacy, data sovereignty and national resilience, and then the very closely associated topic of security. We'll come on to some conclusions. Nir will then talk you through floLIVE's capabilities and what how they see compliance, and then we'll get on to the Q&A at the end. So a little bit about Transforma Insights in 30 seconds. So we're an industry analyst firm. We are coming very much out of the IoT space, but with actually a broader remit than that. We look at a lot of other disruptive technologies, and essentially we help technology adopters and technology vendors to navigate their way through the constantly changing environment, and regulations is a very good example of a constantly changing environment. The constantly changing environments in all of these technology landscapes. So that's us. If you want to know more, I'm happy to talk to you directly about that. But over to you, Nir, to talk a little bit about floLIVE.
Yeah, thank you very much. So floLIVE, we are global providers of cellular coverage for all the IoT use cases, connected service. We serve large OEMs, but particularly we serve MVNOs and IoT service providers in the space. And we also have some nice list of MNOs that are using our solutions, both from a technology standpoint, our technology stack, but also our global infrastructure and our global coverage. And we'll talk later on how connecting this advanced technology with the global coverage can solve some of the regulation issues that Matt is going to cover today.
And then there was a second slide for you, Nir.
That's right. So this is basically an illustration of our network and our technology. So the whole idea of the floLIVE solution is to localize a single global solution, to basically mitigate between the need of having a simple solution that creates operational streamlining, but on the other hand, a solution that at the same time will be compliant in any country, meet the security requirements, but also performance and other things. And that's the localized global network that we are building. Back to you, Matt.
Excellent. Thank you very much, Nir. Okay. And before we get started, I should note that as well as running this webinar today, we've also published a position paper which discusses a whole range of the regulatory topics in probably rather more detail than we can get to in the course of an hour's long webinar, delving into all of the various aspects of regulation. You will find that on our Reports and Insights page. We will send you a link to it after the webinar. Don't go away and download that now. We want you to stick around for the webinar. But once we're done, of course, go check out the report. So, a little bit more background as well. So a lot of the work that we're presenting today is extracted from a quite monumental set of work that we've been doing at Transforma Insights, which is mapping the DNA of regulations associated with a whole raft of different technology areas, IoT being probably the most prominent one, but also AI and a bunch of other areas as well. And we've effectively hunted down I won't say all, because it's almost impossible to be absolutely categorical, but a vast array of the regulations that impact on the deployment of IoT across all of the areas that we'll talk about today, and many others. So that's again another bit of background. But let's get on to the not quite onto the meat of things. Another piece of background on this. I also wanted to note that back at the beginning of 2024, we published what we described as our transition topics for 2024, which was a set of areas, technical, commercial, regulatory, that we thought would affect significantly the way that IoT was going to evolve over the course of the year. And regulation was quite prominently the number one factor that's going to have an impact, or going to see significant change over the course of the year, just because of the volume of regulations that are coming through that will affect things to do with, well, all aspects of IoT. So worth noting that. Now onto the actual matter at hand. First thing to cover off on is vertical regulations. I'm not going to spend an awful lot of time on that. It would take an awful long time to go through every vertical and every use case and the regulations that might affect it. And each one is probably not going to be relevant for everybody else who's attending the call. The point to note is all IoT is vertical, and most companies don't even think of themselves as doing IoT, or certainly companies that are adopting don't think of themselves as doing IoT. They think of themselves as doing remote monitoring or fleet management or building automation or whatever. And not surprisingly, given that all IoT is vertical, a lot of the regulations are also the same. They are vertical. Now, what we noted in doing some of our analysis of each of the different applications and the regulations affecting it is that effectively there's two types of regulations that relate to the verticals in IoT. One set are regulations that need to be complied with, and another set are drivers in the market. So obligations and stimulus or stimuli, I guess. So as an example of the stimulus side of things, you've got in smart buildings, you've got the Energy Performance of Buildings Directive, the EPBD, and the Renewable Energy Directive, the RED, in the EU. So that drives the requirement to do a lot of smart building use cases. At the other end of the spectrum, you've got obligations. Anybody building, for instance, a consumer electronics device has to comply with regulations around product safety and many others. In fact, we'll talk about some of these because they're quite horizontal. But the obligations, or the consumer electronics category, tends to fit more into the topic of obligations. So verticals. That's about as far as I want to go on verticals. Most of what we're going to be talking about subsequently is much more horizontally and broadly related to IoT. But anybody involved in deploying an IoT solution obviously has to understand what the regulations are that are very specific to their sector. And then starting from kind of the bottom up, maybe in the stack, device certification. Let's start with that. the focus here, this is sort of old school stuff really, but still a necessity. It's about making sure that devices don't cause problems for networks or other devices, and that's essentially the role that it's playing. You've got certification by bodies like the PTCRB or regulators such as Anatel in Brazil, which does certification through designated certification bodies. You've got some global entities like the Global Certification Forum, and you have some certification requirements on the part of specific operators. So there is a requirement to comply with that kind of certification. Not a particular change here, though. This has been around for quite some time, but for completeness, we wanted to note it. And there's some other device-related and network-related rules and regulations that also have an impact. Things like RF regulations, who has access to spectrum, what the limitations are in terms of power and duty cycle, and so on, in terms of accessing, say, unlicensed spectrum. So there's a whole raft of regulations there, and some other more commercial related things like import and export restrictions, and then there's environmental regulations, product safety standards, energy efficiency standards, and a range of other topics like that relate to how you build and develop devices. So far, so pretty well understood, I think, and these are well-worn paths in terms of regulation. What is rather more interesting and changing, complex, should we say, is permanent roaming. So if you move from the device slightly up the stack to the network piece, and specifically multi-country connectivity, we get to the issue of permanent roaming. This is actually really a bit of a catch-all term for a whole range of things, but essentially it's whether a cellular device that uses a SIM or SIM profile from an overseas operator can exist in a state of permanent roaming on a network. And that's often the way that cellular-based IoT connectivity for multi-country deployments has been supported historically. Regulators over the course of, starting probably the 2010s, but maybe even a little earlier than that, introduced various reasons for restricting that. That might be based on licensing or company registration or taxation or know your customer or a variety of other reasons. How the regulators have imposed restrictions on the ability to do that. And on this map, we're discussing some of those. The writing may be a little small to read, but it's all in the report, so you can certainly take a look there. Now, some of those are regulatory, some of those are based on government regulations or stuff from the regulator themselves. Sometimes it's commercial, sometimes it's from the operators. We particularly see that in the US, Canada, Australia, where there's been some restrictions imposed by the network operators there, which is unrelated to what the regulator in the market might say. Now, moving on, we've categorized the current state of permanent roaming across a range of countries into 4 categories. But what I should note is that this is not perfect. There are countries where it's permitted, but the restrictions are harsh in terms of registration and so on. And there's others where it's prohibited, but still happens based on specific carrier agreements. So there's a lot of caveats to be added, and it's almost impossible to be absolutely categorical. So, for instance, in the EU, there's no restrictions, but there could be for certain reasons. It's up to the local markets if they wanted to, but within certain very well-defined parameters. And in China, it's prohibited, but some providers have got permanent roaming offerings via agreement with the carriers. So it's maybe not quite as cut and dried as you might hope it would be, given this is the world of regulation, and you would hope it would be black and white. But that's maybe a lesson for all of us. So that's where we stand is in certain countries there is prohibition, in other countries no restrictions, and there's a sort of spectrum of approaches in between, and some kind of fluidity between those categories that also needs to be navigated. And last slide in this section. One of the things that we did as part of our communication service provider IoT peer benchmarking report that was published back in July was, this is a deep dive bit of research. We talked to 25 of the leading connectivity providers, IoT connectivity providers worldwide, do a deep dive on their capabilities and strategies to understand how good they are, how capable they are of supporting particularly multi-country deployments. And one of the exercises we did was to ask, how do you connect devices in these 6 regions? The 6 regions being, again, this is a little small to read, but the 6 regions being EU, US, India, China, Turkey, and Brazil. We could have gone on. There could have been 20 countries, but just for the purposes of this, we decided to focus in on 6. And currently, EU and US, pretty much everybody's got a highly compliant solution across those markets. Brazil, as one of the countries that has been a permanent roaming challenge for quite a while, is one that lots of the players have now got a solution that provides some degree of compliance in. India's a bit unclear on what the environment looks like, and Turkey is very challenging. And there are a number of other challenging markets out there as well, Nigeria and some of the Gulf countries and so on. But there are essentially now 4 options for connecting devices within any given territory, and each of the players will have a different approach depending on who they are and what their capabilities are. So either you could use a domestic SIM from a local provider, which would need managing, would need you need every country to be managed separately, or you could try using a roaming SIM, which might or might not be allowed, or you could use a multi-IMSI SIM, again, still potentially runs into issues with compliance, or you can make use of the increasingly capable set of eSIM and remote SIM provisioning localization options available, or use those in combination with some of those others above. And increasingly, we're seeing a move towards that latter approach. The optimal solution we see is very much localization, and that actually works very well with some of the other data sovereignty elements that I'm going to be talking about a little bit. But before I do that, Nir, I should give you the opportunity to comment on this one, because I know this is an area that floLIVE has been looking at quite a lot.
Yeah, absolutely, and I think it shows up in this comparison table. The solutions for the regulatory needs are not identical in every country. The one principle we know exists, that we need to localize as much as we can, but even localization by itself does not always solve the entire or satisfy the entire needs of the local regulator. For example, in Turkey, you need to do extra steps to be compliant. And therefore, there are 4 methods here on how to get global connectivity with the advantages and disadvantages. But the bottom line is that probably to be really compliant, you'll need more than one method to be able to get to it. And the question always is, how do you basically mitigate between operational complexity and security and regulation, which are in many cases conflicting vectors? And I think that's the challenge, because we know that IoT connectivity is already coming with a lot of friction and issues, and adding the regulation and security needs on top of it is adding more friction. So the question is, how do you keep something fairly simple for our customers, but at the same time you meet regulations in all these problematic countries that Matt, you mentioned before. So I think that's the topic we should be focusing on, and I'll talk about it later on.
Well, I mean, I think the point is that the simplest way to connect every device in every market would be through roaming, if it were permitted, right? I mean, and that historically if you went back 20 years, any IoT or machine-to-machine solution that as we would describe it then, would have made use of pretty much exclusively roaming, and it works. You're managing every device on the same core, and it's pretty straightforward. But that's just not an option in many of these countries, right?
Matt, if I just may add on this one, roaming-based solutions are a problem for regulation and security, but also becoming a problem in terms of performance, latency, and also are in many cases counterproductive to the mobile network operators' commercial needs. So the use of roaming for IoT has different complexities that we need to consider.
Absolutely. All right, we'll come back to these topics, I think, in a little while when we sort of wrap up. But I want to move on now to the next topic, which is privacy, data sovereignty, and national resilience. So what I've pulled together is this quite interesting little chart. We can kind of think of privacy, data sovereignty, national resilience as also existing rather side by side and overlapping with security. And in fact, many of the regulations overlap with each other in all of these various different elements. But really here, what we've talked about is kind of devices and networks up until now. But what we're talking about here is what you can do with data. And it starts with privacy, and we're all familiar, hopefully, with lots of the regulations, both the general regulations. I mean, the GDPR would be a perfect example of that, the General Data Protection Regulation in the EU, and also vertical related privacy regulations, things like HIPAA in the US, and the Personal Information Protection Law in China, and the California Consumer Act. There's Consumer Privacy Act, sorry. And this is all about personally identifiable information, and so applies to many IoT deployments, but certainly wasn't introduced specifically related to IoT, but certainly is applicable. Again, pretty well understood. What's starting, or over the course of the last 3 or 4 years, to let's say emerge, but certainly become much more significant, is a set of rules around data sovereignty. Who can access and share data? Now that sounds rather restrictive, and it often is, but sometimes it's also about establishing open data frameworks. Particularly the EU has been quite interested in that. I'll be talking a little bit about the EU Data Act in a bit, and also about some of the US legislation in a little bit. But this idea of data sovereignty, how you access data, and in some cases encourage its use, in some cases to restrict its use, is quite interesting. And then there's been an evolution from that into national resilience, which, as I mentioned, intersects with the topic of security, and I'll be talking about delve into NIS2 and UK Procurement Act in a little bit. But I think this takes this discussion of permanent roaming being about localization, and kind of extends it into the data domain, right, where everything is starting to become a little bit more local, and the requirements to manage data become much more local, and therefore considerations of how you architect a solution have to allow for that localization of data. I'm sure you'd agree with me on that one as well.
No, absolutely. I think there are 2 dimensions to take into consideration when we look on all these things. The first one is the obvious one, the data protection, and all these things that we need to do for any solution that we build. The second one is the more complex one, is where needed, how do we keep data in region and not letting data to go out of region? It is complex because, again, you can do it with local SIMs or local profiles, but it comes with some heavy lifting operational processes. Or you can do it with roaming, and then you don't comply, or maybe look for the midway that tries to solve it in a way that it's usable on one hand, but compliant on the other.
And there's also an architecting question as well, that local packet gateways and local data breakouts, just to ensure that, okay, the rules might not exist today that require all of the data to be processed in country, but having an approach where not everything is heading back to a centralized core or a centralized data management approach, that kind of makes sense, right?
Yeah, absolutely. And I think that the localization of the network, you mentioned the local packet gateways. This is one of the methods to localize networks. There are other methods that I'll touch upon later on, but localizing the network is a trend that is here for good reasons. We mentioned before some other considerations for data localization, um, and basically the, the localization of the data is not only solving few problems, but it also comes in when you look on eSIM use. eSIM use will basically push the market somewhat towards further localization, because that's the essence of an eSIM profile. So I think that both commercially and from performance, regulation, security standpoints, data localization will be, we believe, the next evolution of the global IoT solutions.
Good stuff. And as promised, I want to jump into just a few examples of some of the regulations that we see doing some interesting things around this topic of data sovereignty. One's the EU Data Act, and that's due to come into force mid-2025 and aimed really overcoming what the EU sees as being a set of barriers to greater sharing of data that's generated by enterprise and consumer IoT devices. So it's very IoT specific, actually. And they think that there's a lack of incentives for sharing, a lack of clarity about the rights and obligations to do so. There's some cost and complexity associated with it. There's a fragmentation of data silos, there's a lack of standards, and so on. And that's what led the EU to introduce this EU Data Act. The key facet of it, from my standpoint anyway, is about access to data, so that consumers and businesses and also government bodies can access data and allow third parties to get access to it. So your data, i.e. data generated by your IoT devices, regardless of who holds it, is accessible to you, which actually allows, I think, has some very positive implications. So it allows for a ecosystem of third-party application developers, either as an alternative to the original provider or as a sort of option to combine IoT data from one solution provider with that of another solution provider. So I think that's quite interesting. Not without its challenges, and there's a certain lack of certainty about the exact impact on things like the architecting of multi-country deployments. It doesn't say really anything about telecom data, for instance. It puts some limits on which vendors can be used. So, for instance, it's prohibition on certain vendors being the new hosts of said data, and there's some concerns about putting trade secrets at risk, and the other interesting element about it is it allows for free switching between cloud providers and puts some prohibition on international transfer of data unless there are agreements or comparable rules between markets. So potentially also there's some conflict with what the US regulations say, specifically the US Cloud Act. So interesting one in that, particularly when we talk about data sovereignty and data sharing, we tend to think about it as being restrictions, but actually this is about opening it up and making it more available for developing new applications. So quite an interesting one. More on that in the report. That more on all of these things in the report actually. Then on to national resilience. The NIS2 directive, again, it's another EU piece of regulation. The EU regulates. That's the term I think. Start was NIS, which was the Network and Information Security Directive, a piece of EU-wide legislation on cybersecurity, which aimed at having a common level of cybersecurity across all member states. Now, slightly ironically, it's a directive, so it's not directly applicable, and each member state needed to implement it in local law. And that expanded then to NIS 2, a sort of extension of NIS to include more sectors and services. And there were three objectives there: increase cyber resilience of businesses in the EU, reduce inconsistencies in resilience of different sectors covered by that existing directive, and improve joint situational awareness. And we should note, all countries have their own specific rules, and all countries have found slightly different ways of thinking about NIS 2 as well. Some going rather further than others. We've seen some of the Scandinavian countries, particularly with some stricter rules about what we might term service availability. Now, you might say, okay, so what about so what for IoT? Many of the use cases covered by NIS 2 will be IoT related, critical national infrastructure, and probably a relatively wide definition of that will be covered by NIS 2. And there's also some implications for how IoT solutions are architected. So if your product has to work in a closed border scenario, which is what's envisaged by some of the regulations or some of the national approaches or national enhancements on NIS 2, how would you architect it? And which vendors would you choose? You have to make sure that the solution you're using is compliant with those kinds of rules. And speaking of vendors, the third one I wanted to talk about here was mostly the UK Procurement Act, and this was quite interesting because this sort of points to a trend around approaches to the vendor landscape. So there's a increasing geopolitical angle. We saw historically some network vendors being prohibited, and this is increasingly being extended to device vendors. So in the UK, the Procurement Act sets out a single set of regulations across government, utilities, defence contracts, critical national infrastructure, and establishes a debarment list for vendors, which will be monitored by this National Security Unit for Procurement as of this month. So some moves in that direction, which are clearly aimed at this concept of national resilience. And in the US, the House Representative Committee has asked for some Chinese vendors to be added to a covered list of companies from the federal government from which it can't purchase equipment. So we're starting to get into quite a multipolar geopolitical world with lots of challenging environments for vendor selection and identification of software, bill of materials, and various things around that, which is interesting to note. So constantly changing, I think, is how I would describe this. Security. So moving on to, or sort of moving sideways into security. This is a topic we touched on briefly. So two aspects to this really. And they demonstrate the evolution in thinking about IoT security. Firstly, what we've termed cybersecurity on the bottom left hand, is really about basic device guidelines. And then that has evolved, I think, to much more substantial rules about what happens with cybersecurity. And to give one example, this is a couple of rules from the UK. First was the Code of Practice for Consumer IoT Security, which came out in 2020. We see these kinds of things the world over. This is guidelines and best practice, and essentially don't do dumb stuff type rule, not quite even rules, but guidelines, guidance on things like devices needing unique passwords, and you don't have hard-coded passwords, and so on. You need some kind of public contact point for vulnerability disclosures. You need a statement on duration for security patches. And we see very similar approaches in many countries with these kinds of guidelines. And clearly they were necessary. I say it's don't do dumb stuff, but clearly there was a lot of devices out there that were doing dumb stuff. Otherwise, you probably wouldn't have got the Mirai botnet and a variety of other of the quite famous security breaches of 5 years ago or so. Just a couple of years after that framework, things got more regulated. So if this was just about a framework, then the PSTI Act actually, the Product Security and Telecommunications Infrastructure Act, actually turned it into a set of rules, and specifically giving the UK Minister the power to specify what the requirements were, rather than within the law stating what the requirements were. So you might argue about the potential for ministerial overreach and so on, but actually maybe it's more a recognition of reality that you need some flexibility to be able to specify what the rules are in a rather quicker way than having to go back to an act of parliament every time. And we see exactly the same thing in the rules that are, as were in the code of practice that previously existed. So it's more or less codifying that, and we see similar things happening in many other countries. I'm just using the UK as one example there. And then in the EU we have the Cyber Resilience Act. I mentioned this before, covering connected devices, and they have to be designed to be secure, include updates, and that came into force this month with OEMs, so device makers having 3 years to adapt to the requirements there. And we note some overlap with NIS 2. So the Cyber Resilience Act forces updates and software patch information to be made available, and NIS 2 puts responsibility on companies to make sure they are complying with required security good practice, essentially. So they need to diligently apply those updates, I suppose. So another example of you sort of seeing these overlapping regulations. And then onto the US. We could do a whole session on US regulatory landscape. Basically the same sort of dynamics as we see in the UK. So you had the Cybersecurity Improvement Act, which set federal government procurement minimum requirements, and asked NIST, the National Institute of Science, of Standards and Technology, to implement a set of guidelines. We saw a set of voluntary standards then as the NIST cybersecurity framework, and then a version 2, which expanded that guidance for industries, including risk management, supply chain risk management, and more scrutiny of suppliers. It then published guidelines on the cybersecurity capabilities expected of IoT products, and then there were requirements to publicize those capabilities and label devices. So just gradually more and more regulation being applied and moving from guidelines into more firm requirements. So conclusions. We've done a very quick whiz through of all of those elements of IoT regulation, of which there were many, and really we were only scratching the surface of most of them. But I would offer these thoughts as a general guidance on what we think around IoT regulations. And Nir, I'll come to you for your perspectives on them once I get through these. But first one is, and I haven't added this caveat yet, but I should add it now, consult a lawyer. We've highlighted key regulations that might impact companies deploying. The implications of the regulations will always be specific to an individual company's situation. So if you want a definitive legal position, you should always take legal advice. I should probably have had that up front as a written piece of comment on the first slide, but that's certainly a true thing. Second point, the regulatory burden is growing. Lots of new regulations relating to IoT have emerged in the last few years. we see in future, I think, a greater level of clarity around the regulations that apply to the IoT, but in most cases they'll be a lot stricter. And some of today's approaches to, for instance, multi-country support and the associated architecture may not work in future. Enterprises need to conduct a rigorous assessment of the regulations that apply to their IoT deployment. You need to identify regulations that are your responsibility versus those that are responsibility of the supplier, and you need to do your due diligence on the latter. So, for instance, in an IoT device, you can think of issues to do with, say, compliance with vertical regulations, device certification, product safety standards. A few other things would fall to you directly if you're an IoT device OEM. Other areas like permanent roaming will be the responsibility of whoever the supplier is. So the focus is on selecting a supplier with a compliant offer. And we should say vendors in the IoT space should be able to explain how their proposition complies with the various regulations, many of which we've discussed here. And you should know your suppliers. It's increasingly incumbent on anyone developing an IoT solution to track the bill of materials, including the software bill of materials of the solution, to ensure and be able to prove auditability, traceability of compliance. I think to draw the strings together of a lot of the things that we've talked about, probably the most complex and critical area relates to the increasing requirement for localization. So a lot of the regulation relates to the need for data to be managed locally, connections to be localized onto a network, hardware or software to be approved by local authorities, and a bunch more things beside. So IoT solutions need to be architected appropriately and becoming rather more localized. So you want to be looking for connectivity solutions and everything else beside connectivity solutions that explicitly tackle this issue around localization. So given the rules from regulators and operators and so on relating to issues like data sovereignty and permanent roaming and so on, they need careful consideration. And if you fail to comply with those regulations, it can result in substantial disruption. So you need some confidence and some explanation of how a solution might meet the requirements, and furthermore look for solutions which are inherently localized in terms of data management, so heading off some of those potential headaches that we might expect in potentially in future, and also prepare for a more polarized and politicized world that sort of plays to the same sort of points, I think. So Nir, over to you. I've flung a lot of key messages out there, but I'd be interested in your perspectives on those ones, particularly I think probably around that localization piece and and obviously around the connectivity piece is particularly your area, I think.
Yeah, absolutely. Thank you very much, Matt, for that. Maybe we can go to the next slide and start talking about it. But if I'm summarizing, as we said before, if I'm summarizing the two major things we need to think of when we aggregate the compliance, security, regulations, we are looking at two main things. Number one is to make sure that the data is protected in different ways. And the second thing is to make sure that data does not go out of region in those regions that do not allow data to go out. Now, you probably know that roaming-based solutions are to some extent violating the regulation when it comes to permanent roaming, or when it comes to having the data kept within the region, because roaming by definition gets some data, network data, to the one centralized core network that in many cases sits somewhere out of region. And therefore, while roaming is still a very good method to solve many problems in the IoT world and make it simple to use and should be used, it cannot always fulfill all the regulatory requirements. And then you come into two other options that Matt mentioned before. One of them is to use local physical SIMs in different countries. And I think that the market is mature by now to realize that this is not really scalable in terms of operational simplicity and the need for working with many different vendors, many different operators, the logistics around it. And the second solution is to use the emerging eSIM capabilities. We are now looking on HGP32 that is just upcoming, and this is another method to localize data. But even eSIM has some disadvantages that we need to realize. You download the profile of a specific MNO in a specific country, you get the coverage of this specific MNO only in most cases. Sometimes it's good enough, sometimes it's not good enough. And you get the availability of this operator only, meaning if something happens, then you are there basically with no way to move and shift. So it's not always easy to or right to use only one eSIM profile in a specific country. And also, it's still more complex operationally than using roaming, because you need to negotiate with different MNOs, you need to download profiles in different countries, etc. So it's not as easy as just using plain roaming, which obviously is not good enough. And also, eSIM may cost a little bit more than the existing solutions, and we need to realize that. And therefore, our approach is that we need to take all the tools that we have in our toolkit, which is roaming-based solutions, eSIM capabilities, and also localization of data in two other ways. One is local IMSIs that you can easily switch to with less complexities of the eSIM. And one more, which is localizing the data using local packet gateways, meaning making sure that the user plane, meaning the device data itself, stays within country. That doesn't solve everything, but it solves many of the issues that comes with regulation, because if you are not allowed to send out of country medical information, then necessarily you need to have local packet gateways if you use any type of a roaming solution to ease the other pains of the IoT connectivity complexities. And this is our approach. Our approach is basically to go country by country in these regulatory tough regions and countries and think on what is the right solution for them. And I can tell you, for example, that for Turkey, the only way to do it is with a profile. You cannot do it with a local IMSI, you cannot do it with roaming. Local plastic SIM cards, we know by now it's not very scalable. So you need to do it in the Turkish way, using the regulators' SMSR download, doing all the certification, providing means for moving your profile from your own profile to the local profile, etc. So this is a very extreme case. For example, in Brazil, you need to have local networks that are approved there by Anatel, and because Brazil is so wide geographically, sometimes doing it with a single network, for example, from Vivo or Claro, is not good enough. And then the question on how you localize data with multi-network in the same country is becoming harder and harder. And this is exactly what we do, meaning because we are the owners of our own technology, we are building in-house the core network technology, the CMP capabilities, and the multi-IMSI applet on the SIM card, which includes the standard eSIM capabilities we're doing with the partner. We can basically choose the right tool to solve the problem in each specific region, but with one principle, which is balancing between the capabilities and the simplicity and the compliance. And the one principle is, don't make it more complex for the customers. If they need a single SIM cards globally, hand them a single SIM card globally that solves the regulatory issues. Don't tell them, hey guys, every country you need to go to, you need a different SIM card, or you need to have different operations like downloading local profiles to solve the problem. No, get a simple solution with full visibility on the entire network, with all the good things that we are trying to bring to streamline the operational complexity of the IoT, and at the same time solve compliance and regulation. And for us, compliance and regulation is number one in priority, because our technology allows us to do that and to highlight the solutions we bring to the market. Matt, if we go to the next slide, please. So basically, we are localizing networks more and more as we go. And here we have kind of an illustration of all the localized networks we've been building, meaning in these countries that we are showing here, the data is local. And as I mentioned before, the data is local in three different ways. Number one, you use eSIM because that's the best method in this specific case. Turkey is a good example. Second method is local IMSI, that you simply get quite easily, more easy than eSIM. When the device gets to the country, that's a second method to localize data that we use. And the third method to localize data that we use is to still use your roaming solution, but to locate packet gateways and use what is called CAPS technology, which is basically to keep the user data within the country, within the region. And the combination of these three solutions, one for for different needs and regions, with keeping that principle of operational simplicity in place, we believe is delivering something meaningful for our customers. And that approach, as I mentioned before, does not only solve the regulatory permanent roaming security needs, but it also brings other advantages when customers are looking for low latency solutions, high throughput solutions, definitely using local IMSI or local eSIM or packet gateway locally, which has the advantage of using multiple networks in the same country. That could solve this as well. So think of it, you can get a local connection, but with 3 or 4 operators in country, all of them are performing on the local connection like local. This is something that cannot easily be delivered with eSIM or with plastic SIM cards or the other means of doing it. And this is exactly where we take the technology to the edge to deliver these solutions to our customers. Back to you, Matt.
There was one more slide of yours. I don't know whether you wanted to talk to this.
You're right, but I think that we wanted to keep some time for questions. I would just say here that security is top of mind, and because we own the technology on the SIM card, on the network, on the CMP, it's all ours, and we always implement our technology around the world. It's simply easier to also comply with the security regulation. I said it in 30 seconds to leave time for questions.
Perfect. One quick thing before we Q&A. It's Q&A slide now. Okay. So I mentioned that we had some questions already lined up, which were asked by people ahead of the session. So I'll go to a few of those now. First one was somebody asking if we could cover regulations relating to ITU E164 International Shared Country Codes. Now I'm going to interpret that as being about MCC 901 International Country Code, because we talked about permanent roaming, but the implication was that that was a roaming SIM from another country, but these rules still apply to what is termed MCC 901, which is non-geographic country code, right, Nir? And that's used by quite a few network operators for supporting IoT, but the regulations apply the same, right?
That's right. 901 IMSI is basically, by definition, is roaming everywhere. There is no home network for 901. So when we use 901, we always need to consider permanent roaming restrictions by all means.
Yeah, it doesn't get a special pass because it's this non-geographic specific. It still counts as a roaming SIM. So yeah. Okay, next question. And this is an interesting one. Do you see more and more demand from telecom regulators to have eSIM platforms, SMDP Plus or SMDP /SMSR, to be in-country deployed? And this is sort of playing to the approach that Turkey's taken, maybe India's going to take. Do you see that happening more?
Well, it does. It's just because it's another mean for the regulators to make sure that they have some level of control on the data and the security of the solutions. And it's also commercially more compelling to put everything in country and let the MNOs also benefit from that. So yes, I think it's a growing trend. It's not purely from regulation perspective, but regulation definitely pushes this trend much further.
It does make things rather more complex, though, doesn't it? If you think about how most people would maybe want to procure from one company providing a kind of eSIM orchestration capability, and you have to have an instance of that in every country, it starts becoming quite a complicated exercise, right? But
it is, and that's the point of always keeping in mind that IoT will be fantastic and growing faster if it's simpler and easier to use. So the mitigation between complexity and compliance is, I think, the most important thing we need to think about as provider.
Yeah, it's a constant struggle, right? Okay, next one. Are there significant differences relating to IIoT versus IoT? There's kind of a definitional question here, I think. But maybe a distinction would be IIoT being critical infrastructure and IoT being more the consumer end and less critical. Thoughts on that one, Nir?
No, definitely there is a difference. If you look, for example, use cases that are being implemented now on connecting electricity meters, countrywide in many different countries and regions, there are specific guidance coming from the local authorities on how to do it, and it normally comes in with more strict set of rules. Mentioned before, they need to have the technology in country, and not only the data, but the technology in country, the technology in the control of the local providers, meaning the MNOs and stuff like that. So definitely, when we come to critical infrastructure, regulation is becoming more and more strict, and we must say that the geopolitical situation doesn't make it any easier, right? All the fears of everyone around this geopolitical tension. If you look in Europe, China, US, all these things further pushes that forward. So yes, this is an increasing trend.
Yeah, for sure. And I think we see I mentioned the NIS2 directive and those enhancements on the NIS2 directive in certain countries, and that is focused on infrastructure, which includes, I think, things which will be termed as IIoT, and the requirement to work in a closed border situation and have local data management and so on is certainly a thing, or increasingly. Okay, so for a truly global rollout of an IoT device, actually, there's a couple of questions here which are related to device certification. In what specific cases is GCF certification required? Which countries require regulatory testing to be carried out locally in their own country? And a separate question, what are the minimal requirements for certifying an IoT device for LPWA? Thoughts across those 2-3 questions, Nir?
Yeah, because we have 1 minute left.
Yeah.
Obviously, we cannot talk about the specific countries one by one. Device certification with the network, with the cellular network, is a key requirement almost anywhere. I would just say that. And we see the operators, while they build their certification labs, they're always updating their requirements to make sure that they can protect their network. So this is a completely unavoidable step to take when a new device is coming to market, to make sure that in these countries it needs to operate. It operates within the operator's guidelines. And then when we're talking about low power, there are some extra steps to be taken when we talk, for example, about narrowband IoT, in terms of certifying the devices to the network, etc. But it's the same rule, meaning you cannot be successful with global rollout of your device if you ignore the MNO's guidance on how to make it certified with the networks. It is true for every devices, and even more so for narrowband IoT devices.
We're pretty much at time. Selfishly, there's a question here: are there companies and organisations that specialise in tracking and disseminating IoT regulations? Transforma Insights does that through our IoT or our regulatory database. So that's very, very quickly I can cover off on that one. But just a couple more. One more slide. And just to remind you that this position paper is available. It's called Meeting the Increasing Regulatory Challenge in IoT. It's out today. You'll find it at the top of our Reports and Insights page. You will need to register, but it's free. You can access that report from there. There were a few more questions quite a few more questions that came in during the course of the session. Sorry we didn't get time to answer all of them, but we will respond to you via email. And I hope you've enjoyed the session. Nir, I should say thank you to you for your contributions, and thank you to everybody who's tuned in.
Thank you very much. Great questions are coming in, so we'll be very happy to continue the conversation afterwards. Thanks again, Matt, for hosting it.
Absolutely. The best questions came in about the last 30 seconds of the session, which doesn't give us much opportunity to answer them, but we will get back to. Thank you all very much.
Thank you very much. Bye-bye.